Statistical estimation. Statistical estimation is the process to obtain a numerical estimate of a population parameter using data from a sample. Okay. We can say estimation is simply just a guess. Okay. And an example of a population parameter, such as the prevalence of HIV in Florida. Okay, that's a population parameter we're interested in learning. So that's an example of population parameter. And usually we assume a probability model. We use a function, the probability distribution f of theta. Here theta is a population parameter. And then we use theta hat to represent a statistical estimate. Okay, the hat means this is the value estimated from data from a sample. Okay, and in the statistical estimation or statistical methods we are going to learn, there is a very commonly implied assumption that the sample is IID. IID here is independent, identically distributed. So basically we assume the sample is obtained by simple random sampling. And theoretically we can show that as long as the sample size is large enough, a simple random sample can lead to a representative sample of the original population. So that is why many statistical methods we learn in classes or in textbooks have this assumption that the sample is IID. It's a simple random sample. And there are two types of statistical estimates. One is we call a point estimate. A point estimate is a numerical value computed from data from a sample, using data from a sample. So basically it's just one number. Okay, for example, the prevalence of HIV in Florida, we say, oh, maybe it's 11%. That's just one single number. Okay, and another type of estimate is called a confidence interval. A confidence interval is a range of possible values for which the true parameter falls within the range with certain probability. We call it confidence level. Okay, you should still remember such as the 95% confidence interval for the normal mean, right? That's a confidence interval. So we assume the true value lies in that confidence interval with 95% probability. Okay, so you have point estimate and you have confidence interval. And confidence interval is always preferred than point estimate because it really shows you the uncertainty in the data when we use the data to estimate a population parameter. So there are different ways we can do statistical estimation. So how do we evaluate the quality of a statistical estimate? So for point estimate, there are two indices or two measures. One is called the bias, the other is called the precision. Okay, the bias is mostly reflecting the means of the true parameter, the mean of your estimate and the true parameter value, and precision is the variance of your estimate. So on this slide you can see the graph about precision and bias of a measurement system. So if you think your statistical estimate is a measurement system, then you have these four scenarios. You have precise but biased. Okay, so it's off the target, but the points are very close to one another. You have unbiased but not precise. So overall, the average is close to the true value, the center, but the points are all over the place, very scattered. Okay. And then you have not precise and biased. So this is the worst scenario. Okay. And you have precise and unbiased. This is the best scenario. So statistics estimation is about finding the estimate, which are precise and unbiased. For confidence interval, two most important indices are the width of the confidence interval, so how long, how wide the confidence interval is, and then there's the coverage probability of the confidence interval in repeated sampling. So a confidence interval is kind of a formula that you can compute the interval given the data from a sample. So if you have many different samples, you can compute many different confidence intervals. So you can generate different intervals, and you can count how many times this interval captures the true value. So that gives you the coverage probability. Okay. So the coverage probability of a confidence interval should be close to the nominal coverage probability, which is, for example, if you have a 95% confidence interval and you generate 100 interval based on 100 random sample, you should expect 95 of them should contain the true value, and then you have a good confidence interval. Alright. So commonly used statistical estimates, you need to learn about formulas and software implementation for computing all these statistical estimates. You learned all these in the introductory statistics course. So for example, you learn how to compute a sample mean and sample variance, sample proportion and sample variance of the sample proportion, Pearson's correlation coefficient, sample covariance of two random variables, least square estimates of the intercept and the slope of a regression line, confidence interval for a mean, confidence interval for a proportion. Okay, those are some examples of the statistical estimates you have learned previously.